Hello everyone, I am Madhuri, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. So I am going to deal with the DC machines course in this particular semester. So first I am going to introduce the course to you all and what are the contents or what are the topics we are going to cover in this DC machines course I am going to discuss in this particular course. So coming to the contents, first, we are going to introduce the introduction to the DC machines. We know that the DC machines are the electromechanical conversion devices. So DC machines means we actually deal about the motors, DC motors and DC generators. We know that a DC generator is a one such device which converts the mechanical energy to the electrical energy, and the DC motor is nothing but a device which converts the electrical energy or the electrical power to the mechanical power. So what are the various working principles involved in studying about the motor and the generator, and what are the respective constructions we are going to study in detail about the different types of DC generators and DC motors are also going to be covered in this DC machines course. And we know we have various applications for this DC machines course, that the DC motors and DC generators find their applications according to the power ratings and current ratings of the various load applications on them. So this course we are going to discuss the contents in this particular course in detail. So unit 1 or the first topic in the DC machines course will be about your DC generator. So in DC generator, as we know that these two are the electromechanical conversion devices, so we will be in detail studying about the electromechanical energy conversion principle in DC generators and what are the various laws involved in this electromechanical conversion principle. Basically, we'll be studying about the Faraday's laws in detail, Faraday's laws of electromagnetic induction in detail, and we'll also be studying about the various laws like Lorentz force equation. We will be also studying about Fleming's left hand rule. We will also be studying about right hand thumb rule. So all the basic laws which are involved in making the electrical energy being converted to mechanical or vice versa will be studied under this electromechanical energy conversion principles in detail. Then we'll be studying about the DC generator. First, we will be studying about the principle of operation. What are the various laws involved in the working principle of DC generator? We will be studying about it. Then the construction, that is, what is a stator and what are the parts which are situated in the stator. And then we'll be studying about the rotor and what are the various parts of rotor and what are their respective functions will be studied here. So apart in the construction of DC generators, we'll be studying about the stator and rotor and the parts which are located or situated for the stator part and the rotor part and the respective functions. We'll be studying in this. Armature windings. Armature windings is nothing but it is a part of a rotor. That is nothing but we have armature in rotor. Armature windings are placed in armature. So we'll be studying about the armature and what are the various types of armature winding. We'll be studying about in this topic. And we know that there are basically two types. We have lap winding and wave winding for our armature windings. Again, there is a sub-classification for lap windings and wave windings in the form of simplex, duplex and triplex windings. So what are their respective structure? What are the respective diagrams of both the lap windings and wave windings and their constructional features? All will be discussed under the topic called as armature windings in unit 1 of DC generators. Then we'll be discussing about commutator. Commutator is nothing but a mechanical rectifier which converts all the alternating quantities in the armature to direct quantities. So we will be studying about the commutator and what is commutation action, how is it happened in the armature of the DC generator will also be studied under commutator. Then we'll be studying about the EMF equation of the generator and how it is derived, derivation of the EMF equation of the generator, and what are the various factors upon which the induced EMF or the generated EMF in the DC generator is being dependent upon will be clearly stated in the EMF equation of the DC generator. Then we'll be studying about what are the various types of DC generators. So we basically have 4 classifications, 4 kinds of DC generators under which we have separately excited DC generator. Then we have series. Under types of DC generators, we have separately excited DC generators. Then we have self-excited DC generators. Again, under self, we have 3 categories. We have series, we have shunt generators, and then we have compound generators also. The respective circuit diagrams and their operation, and what are the respective current, voltage, and power equations of all the types of generators will be detailedly discussed about in this topic called as types of DC generators. Then we have armature reaction. Armature reaction is nothing but effect of armature flux, the flux which is generated in the armature on the main field flux will be studied in armature reaction, and what are the effects of armature reaction like cross magnetizing effect and demagnetizing effect will be studied clearly, and what are the methods to avoid the or to reduce the effect of armature reaction in the DC generator will all be studied in the armature reaction concept. Then coming to the load characteristics. Load characteristics are nothing but called as performance characteristics of a DC generator. Again, here we basically have 3 types of characteristics. First one is open circuit characteristics. The second one is internal characteristics. And the third type is external characteristics. So all these characteristics will be detailedly discussed under the topic load characteristics of DC generators. Then we'll be discussing about the applications of DC generators. And then we'll cover some numerical problems on all the above topics in Unit 1. So this is about Unit 1. Moving on to Unit 2. So Unit 2 is completely about DC motors. So DC motors, again, as we studied about the working principle in generators, we are also going to study about the principle of operation of DC motors. And basically we have 2 laws here. Lorentz force law along with Faraday's laws and also Fleming's left hand rule. All this will be studied under the topic of principle of operation of DC motor. Then we'll be studying about the back EMF. What is back EMF and what is the significance of back EMF? In significance of back EMF, we are going to study 3 cases. That is no load condition, full load condition, and the partially loaded conditions. And how does a motor act with respect to the back EMF is also going to be studied under the significance of back EMF. So these are the 3 cases which we study under the back EMF. Significance of back EMF. Then we'll be studying about the derivation of torque equation. What is the torque and we know that torque is a twisting moment in any rotating device. So what is a torque equation in the DC motor and what is the derivation of torque equation, and how does this torque depends upon the various factors upon the mathematical relation which is arrived at the derivation of the torque equation of DC motor will be studied clearly. Then we'll also derive the condition for maximum power being developed across the armature of the motor. Then we'll be studying detailedly about the types of DC motors, and under types of DC motors we'll be studying about again the classification. So we have separately excited machines, And self-excited machines, same as in generators, we have the same classification in motors. Again, under self, we have three types: series, shunt, and compound. So about all these, we will be studying the respective circuits, what is the current relation, voltage relation, and power relation of all the motors will be studied in this particular topic called as types of DC motors. Then moving on to the characteristics, as we have seen the same characteristics in DC generators, we are also going to see the characteristics in DC motors. So characteristics in DC motor are nothing but torque and speed characteristics, torque and armature current characteristics, IA or IA. All these characteristics will be studied under the torque, the characteristics of motors, various types of motors. These characteristics can also be called as load characteristics or performance characteristics. So these characteristics will be studied for all the types of motors under the classification, that is, it will be studied for series, shunt, and compound machines. So what are the different load or performance characteristics will be studied for all the three types of self-excited machines or DC motors will be studied. We will also be covering the numericals on torque equation, back EMF, types of motors, the three types of motors, and we'll be also covering about the efficiency calculations, and we'll also be covering about the losses. What are the various losses? We have core losses, copper losses. Apart from this, we also have stray losses. All these kinds of losses will be studied under the losses concept, and how does these losses affect the efficiency of the DC motor will also be clearly studied under this topic. Then we'll be studying about the condition for maximum efficiency. What is the condition to be? Derivation of this condition will be derived, and we will also get to know what is the condition required for achieving or attaining maximum efficiency in DC motors concept. So this is about unit 2. All these topics of DC motor will be studied under unit 2. Moving on to the next unit, unit 3. Testing and speed control of DC machines. So we have different methods of testings here. So these are the 6 types of tests which will be conducted on the DC machine. We basically conduct a test on any machine to check its reliability, to maximize its efficiency, maximizing the efficiency means increasing the span of the machine and also its durability. So under testing methods, we make the machine undergo various kinds of tests, and every test has its particular importance in this. So first, coming to Swinburne's test, and we'll also be studying the numericals on all the types of tests under this testing and speed control method. So we'll also cover numericals on all the testing methods of the DC machines. Then coming to speed control method, we basically have armature voltage control method and field flux control method to control the speed of either DC generator or DC motor. So in armature voltage control method, we connect a rheostat or a resistance in series with the armature winding, whether it may be motor or generator. So we vary the position of this rheostat and we accordingly control the speed of the machine. So by using the armature voltage control method, we always get the speeds above rated speed. Consider if the speed of the motor or generator is 1500 RPM. While we apply this method of speed control, we get the speeds above rated speed. And the field flux control method is nothing but when we connect a rheostat in series with the field or the resistance in series with field, and we vary this resistance to vary the field current in the field of either motor or generator. So by using this method, we get speeds always below rated speed. So these are the basically two types of speed control methods which will be discussed under the topic of speed control of DC machines. It will be for this DC motors and DC generators. These two methods of speed control will be discussed according to their constructions. And what are the types of starters? So starters are basically the devices which are used to protect your motor or generator from the high inrush of starting current. So what are the various kinds of starters will be discussed under this topic, types of starters. So this is about unit 3 of DC machines. Moving on to unit 4, we have about the single phase transformers. So single phase transformer, we know that as the transformer is an AC machine, but it will also be studied under the not DC machines concept, but it is an electrical machine or an AC machine. So under transformers, we'll be studying about the principle of operation, what is the construction of transformer, and what transformer usually works on mutual induction. Mutual induction, how does it happen between the primary and secondary circuit of transformer, will be clearly studied under the principle of operation. And construction, what are the various parts of transformer, will be studied under the constructions topic of transformer. So we basically have a core, windings, we have transformer tank, transformer oil, and other respective parts. Other main important respective parts will be studied under the construction topic of transformers. Then we'll be studying about the types of transformers. The types of transformers, we divide the classification of transformers based on the supply, based on the windings, based on the power, and based on the application. So what are the various types of transformers? Based on all these types of categories will be discussed clearly under the topic of types of transformers. Then coming to the EMF equation of the transformer, we are going to derive the EMF equation of transformer. For both the primary winding and secondary winding, what is the EMF equation of the transformer will be clearly discussed under this topic, EMF equation. Then we are going to discuss about the operation of transformer under no load condition and loaded condition. What happens, how does the operation of transformer change when we apply load on the transformer and when we do not apply any load on the secondary side of transformer? What are the respective primary voltage and current, secondary voltage and current, and what are the respective induced EMFs will be clearly studied under the transformer operation of transformer under no load and loaded conditions. Then we'll be studying about the phasor diagram. The phasor diagram of the same transformer operating under no load condition and loaded condition, including all this terminology, that is primary voltage, secondary voltage, primary induced EMF E1 and secondary induced EMF E2, and the primary current I1 and the secondary current I2. So how do we represent all these parameters in the phasor diagram will be clearly studied under the phasor diagram concept of transformers. Then we'll be studying about the equivalent circuit of transformer. Equivalent circuit of transformer is nothing but an equal or a similar circuit which resembles all the primary, when all the primary quantities are referred to secondary side and similarly vice versa when all the secondary quantities, that is nothing but secondary current, secondary voltage, secondary induced EMF, are referred to primary. So how do we represent all the different quantities of primary winding and secondary winding in one equivalent circuit will be discussed in the equivalent circuit of single phase transformer clearly. Then we will be discussing about the efficiency. Before discussing the efficiency, we will be discussing what are the various kinds of losses. So various losses will be discussed under this topic. We mainly have core losses, copper losses, we have stray losses. So all this kind of losses will be discussed, and how does these losses affect the efficiency of transformer and regulation of transformer. Regulation of transformer is nothing but change in voltage from no load condition to full load divided by no load condition. So how does this regulation, what is the regulation of transformer and what are the various numericals on this topic, regulation and efficiency, will be covered together. Then we'll be studying about the testing of transformer, polarity test, OC and SC test, heat run test, parallel operation and problems. So polarity test, this is a dot convention method of both the windings. Will be studied clearly under polarity test, and what are the respective induced EMF, how does they oppose the supply voltages. All this terminology will be studied under the polarity test. OC test, usually to find out the iron losses, we conduct open circuit test on the transformer, and to find out short circuit test is used to find out copper losses. And then we heat run test. What is the amount of heat being generated in the oil of your transformer when the current will flow through the primary and secondary windings, and how much amount of heat can a transformer winding withstand can be known under this by running this particular test. And then we will study about the parallel operation of transformers when two or more transformers are connected together. How your voltage, current and induced EMF parameters change respectively, and what are the conditions required to run two transformers in parallel operation, and what is the output that will be delivered by operating the transformers parallelly. And then we'll also cover the numericals or the problems on the topics of efficiency, regulation, equivalent circuit of transformer, EMF equation. All this will be studied, the numericals will be clearly discussed on the topics of the above EMF equation, equivalent circuit, regulation and efficiency. So all these topics will be covered under numericals in single phase transformers. This is totally about the contents which are going to be covered in the DC machines course. So in summary, we have discussed what is DC machines course and what is its importance, and what are the contents of the DC machines course, which I am going to discuss throughout this course. We have seen 4 units about DC generators and various topics related to DC generators. We have discussed about DC motors. Then we have discussed about the testing and speed control of DC machines. Then we have also discussed about transformers, single phase transformers. All these topics will be covered under this course. Thank you.